Just off the coast of Africa, a Spanish island hides one of Europe's most terrifying geological secrets. At first glance, it looks lifeless, a scorched wasteland of black lava, shattered mountains, and endless volcanic craters stretching toward the Atlantic Ocean. But beneath this silent landscape, the Earth is still dangerously hot. Water poured into the ground erupts back out as steam. Temperatures just below the surface can reach hundreds of degrees. More than 2 centuries ago, the island experienced one of the longest volcanic disasters in European history, and scientists now believe the forces responsible never truly disappeared. Deep below the surface, the volcanic system that once devastated the island is coming back to life. This is the Timanfaya National Park volcanic field, one of the most active and dangerous volcanic systems in the Atlantic region. At first glance, it feels ancient, as though these eruptions happened in some distant prehistoric era. But much of this landscape is shockingly young. The black lava deserts that dominate western Lanzarote were created only a few centuries ago during one of the longest volcanic disasters in European history. For 6 terrifying years, beginning in 1730, the earth split open across Lanzarote. The eruption did not come from one volcano. New fissures repeatedly opened across the island. Entire volcanic cones formed almost overnight. Lava fountains erupted from multiple vents simultaneously. Ash buried crops across vast areas of Lanzarote. Toxic gases filled the air. Villages vanished beneath molten rock. Farmland was buried under meters of volcanic debris. Thousands fled as the island entered a prolonged geological nightmare. And the most unsettling part is this: the volcanic system beneath Timanfaya did not die. Scientists still detect geothermal heat beneath the lava fields. Earthquakes continue to occur beneath the Canary Islands. Magma remains present deep underground. And modern eruptions elsewhere in the archipelago have reminded the world that the volcanic engine beneath these islands is still very much alive. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The origins of Timanfaya begin far beneath the Atlantic Ocean. The Canary Islands were formed by a deep mantle hotspot, a plume of rising magma originating from within the Earth's mantle. As the African tectonic plates slowly moved over this hotspot across millions of years, repeated eruptions built volcanic islands one after another from the seafloor upward. Unlike volcanoes located directly along tectonic plate boundaries, the Canary Islands exist in the middle of the African plate. Their volcanism comes not from colliding plates, but from magma rising through weaknesses in the crust caused by this persistent hotspot. Lanzarote and nearby Fuerteventura are the oldest major islands in the chain. Because of their age, scientists once assumed they were entering a relatively quiet geological phase compared to younger islands such as La Palma or Tenerife. But history proved otherwise. The island's volcanic structure is complex. Rather than one towering central volcano, Lanzarote contains extensive volcanic fields composed of fissures, cones, vents, lava plains, and buried magma pathways. This style of volcanism is particularly dangerous because eruptions can emerge across broad regions instead of a single predictable crater. Modern visitors to Timanfaya often describe the volcanic field as extraterrestrial. The comparison is understandable. The lava plains appear frozen in motion, like oceans suddenly turned to stone. Some surfaces are smooth and rope-like, formed by fluid basaltic lava. Other regions are chaotic fields of sharp, fractured rock lava, created when thicker lava cooled and shattered during movement. Volcanic cones rise everywhere across the landscape. Many are coated in black, red, and orange scoria, produced by explosive lava fountains during the 18th century eruptions. The terrain contains lava tubes, collapsed chambers, pressure ridges, volcanic bombs, and giant fissures. Little vegetation survives across large portions of the field because the lava is geologically young and the climate is extremely dry. NASA and ESA researchers have even studied Lanzarote as an analog environment for Mars, due to its volcanic terrain and extreme conditions. but the most remarkable feature is what exists beneath the surface. The ground is still hot. One of the most famous demonstrations inside Tamanfaya National Park involves geothermal heat. Just a few meters below the surface, temperatures can exceed 300 degrees Celsius. This lingering heat exists because the volcanic system beneath Lanzarote never fully cooled after the 18th century eruptions. Large masses of magma and intensely heated rock remain underground, slowly releasing thermal energy upward through fractures and porous volcanic layers. The geothermal activity does not mean an eruption is imminent. Volcanoes can remain hot for centuries after major eruptions. However, it is powerful evidence that the volcanic field is still connected to active geological processes below. Tamanfaya is not extinct, it is dormant, and dormant volcanoes can wake up. The dangers associated with the Tamanfaya volcanic field are often underestimated because the landscape appears stable and heavily visited by tourists. But volcanic fields are deceptive systems. Unlike classic cone volcanoes with clearly defined craters, fissure systems can erupt from multiple locations with little warning. New vents may open along fractures kilometers away from previous eruptions. This makes hazard prediction far more difficult. If volcanic activity returned to Lanzarote, the island could face several major threats simultaneously. The most obvious danger would be lava flows. Tamanfaya's historic eruptions produced extensive basaltic lava capable of traveling across large distances. Although basaltic lava generally moves slower than pyroclastic flows, it destroys nearly everything in its path. Lanzarote today is far more populated than it was in the 18th century. The island also depends heavily on tourism. A moderate eruption could cripple the economy almost immediately. Ashfall would create another major problem. Even relatively small eruptions can produce volcanic ash capable of shutting down airports, contaminating water supplies, damaging machinery, and causing respiratory issues. Tourism across the Canary Islands could collapse during prolonged volcanic activity. Volcanic systems rarely awaken quietly. Before eruptions occur, magma moving underground fractures surrounding rock and creates earthquake swarms. These quakes may begin months or even years before an eruption reaches the surface. The Canary Islands regularly experience low-level seismic activity related to volcanic and tectonic processes beneath the archipelago. Most earthquakes are too small to cause damage, but changes in seismic patterns are closely monitored by Spanish scientists. The eruption of Cumbre Vieja in 2021 demonstrated how quickly unrest can escalate. Before lava erupted on La Palma, thousands of small earthquakes were detected beneath the island. Ground deformation increased. Magma rose upward through the crust. Then the surface finally ruptured open. The eruption lasted nearly 3 months and destroyed thousands of structures. For scientists monitoring Lanzarote, La Palma served as a modern reminder that the Canary hotspot remains active. What happened there could eventually happen elsewhere in the archipelago, including Tamanfaya. No scientist can predict exactly when another eruption will occur on Lanzarote. It could happen in decades, centuries, or even tomorrow. Volcanic systems do not follow human timelines. However, geologically speaking, the island remains active. Studies using seismic imaging and geophysical surveys suggest magma reservoirs still exist beneath Lanzarote and the surrounding crust. Heat flow measurements confirm ongoing geothermal activity. The island's eruptive history also shows repeated phases of volcanism separated by long, quiet intervals. That pattern is important. Many volcanic fields remain dormant for centuries before suddenly reactivating. From a geological perspective, the gap between the Tamanfaya eruptions and today is relatively short. The existence of the 1824 eruptions proves the system already reawakened once, after the great 18th century disaster. Future activity is not hypothetical. It is expected eventually. The real uncertainty is when and how large the next eruption could be. Despite the risks, people continue living on Lanzarote because volcanic landscapes also create opportunities. The island's dramatic scenery attracts millions of visitors annually. Volcanic soils can eventually become fertile for agriculture. Geothermal energy offers potential future benefits. Lanzarote has also become a global example of adapting to volcanic terrain. The island's architecture, farming methods, and tourism industry are deeply connected to its geology. But beneath that adaptation remains an uncomfortable truth. The forces that created Lanzarote have not disappeared. Deep below the island, magma still exists within the crust. Heat continues rising toward the surface. Earthquakes still ripple beneath the Canary Islands. And the black lava deserts of Timanfaya remain as evidence of what this volcanic system is capable of doing when it awakens. One day, somewhere beneath Lanzarote, magma will begin rising again. Earthquakes may start first, then ground deformation, then gas emissions. And if the crust finally breaks open once more, the Timanfaya volcanic field could remind the world that the landscapes we call dormant are often only waiting.